So we have some problems involving radical equations as well. So where we've seen this before is in our special triangles. So when we have our special triangle of 45 degrees, this is basically half of our square. Okay, so this is one of our perfect shapes, and we can work this out exactly because we know the symmetry of this object, and we know this is 1, 1, and we can find out the length of the hypotenuse by using Pythagoras. Here, the same thing. This is half of an equilateral triangle. Okay, that's another perfect shape. We know the symmetry of it. We know this is 2, 2, 2. And so if I take half this triangle, we have 2 and 1, and we can work out that third side using Pythagoras. Okay, we get our 30-60 triangle. Now, when we have these triangles, because they are perfect shapes and we know the symmetry, we use exact values for these, because we can find the exact. We don't have to approximate. It's not something we need to measure. We know exactly what those lengths are due to our symmetry. And we can use these proportions then to find exact measurements of these unknown sides. So if I want to find out the length of A, B, C, and D, I can use the ratios here. There's a few different ways I can do it. I can use this as similar triangles. Okay, ratios between, just say this, understand that the ratios between is a scale factor. So between here and here is a scale factor of 3 root 5. Okay, so this is a proportional relationship, so it's all about times and divide, if we can find our times and divide factors. The other thing that we could do is we can set a ratio within the triangle, and these are our trig ratios. So 1 to 1, root 3 root 5 to b is the same ratio as 1 to 1. So I'm going to do this first one using a trig ratio. So I know that the ratio of 1 to 1 is equivalent to 3 root 5 to side b. Okay, so 1 to 1 is equal to 3 root 5 to b, which means that 3 root b is equal to 3 root 5. Okay, so if we don't need to set up a ratio for that necessarily, but we can see that there's our multiplier. Okay, we can use our multiplier of times 3 root 5, or we can do our up and down multiplier times 1. Okay, we can just do times 1, and b is equal to 3 root 5. You can solve this as an equation if you like, cross multiply. You can just use intuition if you like. So here we can solve for a using Pythagoras. We can use the scale factor ratio, okay, of times by 3 root 5, or we can use a trig ratio. So I want to use a trig ratio again to do this. To solve for side A, I'm going to use the ratio 3 root 5 to a is equal to 1 to root 2. Okay, so the vertical side to the hypotenuse is the same as the vertical side to the hypotenuse. Again, the direction is important. Okay, here we can solve for a. You can use any method to solve for a. You can cross multiply. You can use a multiplier. I'm going to use this multiplier times by root 2. And I'm going to times by root 2 to solve this. So I get a is equal to 3 root 5 times root 2, or 3 root 10. Okay, so that's one way to do it. Some of you may have chosen to solve this algebraically. Solve for a algebraically, you need to times both sides by a and divide both sides, or sorry, multiply both sides by root 2. So we end up with root 2 3 root 5 is equal to 1 times a. Okay, so a is equal to 3 root 10. So that would be an alternative method. And a third method you could use in this case would be just use Pythagoras. We can say that 3 root 5 squared plus 3 root 5 squared is equal to a squared. So we end up with 9 times 5 plus 9 times 5 equals a squared. This works out to be 45 plus 45, and a is equal to square root 90. Okay, and we'll just use a principal square root since we are just using side length, so we'll get rid of the minus and then simplify that into 3 root 10. Okay, so those are 3 different ways you could have solved for that side A, and reminder that we want to keep these in exact values. For C and D, we can do the same thing. I'm going to use a trig ratio for C, so I'm going to look at my triangle here. I know I'm going to use root 3 and 2. So I'm going to say that root 3 to 2 is equal to side C to 3 root 27x. Okay, and then I can just cross multiply here, so I end up with the square root of 3 on the outside, 81x, and that's all over 2. That's going to give me side C. I should simplify that. There's a perfect square there, so I factor out the 9, multiply it times 3. I'm left with x and all over 2. So there's my value for C. For D, we can say that this is exactly half of this length. Okay, we can use a ratio D to 3 root 27x is equal to 1 to 2 on our special triangle. And again, we can just solve this algebraically if you like, and we end up with 3 root 27x all over 2. And we could factor out the 9 there, so we end up with 9 root 3x all over 2. Okay, and again, if you want, you could have used Pythagoras. You can use a scale factor. We can say that there's a scale factor between these two triangles, and we can find that scale factor by dividing. We find any multiplier. The way we find multipliers is we divide. Okay, dividing two numbers will always find a multiplier in a proportional equation. Okay, so there are a few different strategies there. You need to be confident with at least one. You should have a variety of strategies when in case you get stuck with one.